and amazing people, welcome to Physics Time with Winter. Today we're going to learn about quantum physics. But first, what is quantum physics? Before we get started with that, I would like to let you know, you get a shit book, you get a shit book, we all get shit books! You know, if you join track, you get 5 shit books. I'd like to give a shout out to the track team.
Welcome to Physics with Shed. Sorry about that, a little bit of a pest problem.
Hey.
Last week we looked at what mass and motion was, or momentum. If you take the mass multiplied by the velocity, that gives you the object's momentum. We also looked at, to change that object's motion, you need to apply a force and a time, which is also known as impulse. What we're going to do this week relates to the lab we just got done doing. What we're going to do is we're going to look at how to change the momentum between 2 different objects.
Am I done yet?
No! Keep sweeping!
Okay.
What you should have seen in the lab is that the final momentum after the crash was slightly less than the initial momentum. But that's because there's an outside force present.
Like friction?
Yes, like friction. If there was no friction, then the total momentum of the first cart should have been completely transferred to the second cart. And that is known as the conservation of momentum. We're going to look at 2 different types of collisions. We're going to look at elastic collisions.
Elastic!
And inelastic collisions.
Inelastic!
Elastic collisions is where the 2 objects completely bounce off each other. It's where the total kinetic energy is conserved, meaning the total kinetic energy before the collision equals the total kinetic energy after the collision. Now, be aware, this is only true for elastic collisions. It's not true for general. So if you're doing a momentum problem where there's an elastic collision, kinetic energy is conserved. Inelastic collisions is where the 2 objects come in, they hit, and they stick together. It's where the final velocity for both objects is the same. Just so you know, in real life, not every collision is completely elastic or inelastic. They're all mixes of one or the other. In fact, elastic collisions are very hard to produce which is completely elastic. The only real cases where it's completely elastic is where you get down to the quantum world, where things are bouncing off each other all the time. One more scenario we're going to look at is known as an explosion. We see explosions all the time. Think of a stick of dynamite. If you have 1 stick of dynamite, the total momentum before it explodes is 0. There's no piece of it moving. It has 0 velocity, 0 momentum. Once it explodes, it has tons of tiny pieces flying off into many different areas. If there's no energy lost to outside forces, then if you add up the momentum to each individual piece, it should all equal 0. Remember, momentum is a vector, so direction matters. Pieces flying to one direction might be moving in the positive direction, while pieces moving in the opposite direction would be negative. If you add them all up, they equal 0. Just like Newton's second law, where the net force in the x direction was completely independent of the net force in the y direction, momentum in the x direction is completely independent of the momentum in the y direction.
Mr. Chef, does that mean we gotta break down momentum into components?
That's exactly what it means. What are you still doing here?
My car broke down and I forgot my order card.
Get out! Get out! Get out! Get out!
Okay.
I know that seems daunting at first, but it's not so bad. First, start with the conservation momentum formula in just one direction, like your x. You might have to find certain components of certain velocities if it's moving in 2 dimensions, but you already know how to do that using sine and cosine. And then solve for the missing variable. Once you know all of the different missing variables for the x direction, you can go ahead and solve for the y direction. And you know that because it's a conservation momentum, the total momentum before the collision is going to equal the total momentum after the collision. Alright, so that's pretty much it for conservation momentum. Make sure you guys take good notes. Make sure you guys... Winter, what happened?
You told me to go home, and I got mud.
You got mud. Let me call the police.
Hey guys, to get credit, put 206 on the top left corner of your quiz. Alright, bye.
Hey, where happened to all this makeup? Winter! Winter! Now time for some problems.
What is quantum physics? But first, you get a shut book, you get a shut book, we all get shut books! Wait, join track.
Welcome to What's Up with Physics. No, that's not it! What's that? 5. Wait, shove them in your pocket.
Bro, you almost killed me with this staple.
Here. Sorry about that. A little bit of a pest problem.
Hey!
Last week. Sorry. Go, alright. Hey!
Quidditch. We need a tennis ball. We're gonna play Quidditch. I got this bitch.
Yeah, just right there, just so I can kind of peek at it.
We're playing Quidditch.
You look around, and you just start, make it rain!
Okay, quiet. Right on set.
No students were harmed today. Good and finished. Wow.